Assalamu alaikum. Today we will study example 10.10. It is stated that the diameter of ball bearing are normally distributed with mean 0.6140 inches and standard deviation 0.0025 inches. Determine the percentage of ball bearings with diameters less than 0.608. As we know that the standard deviation is 0.0025. It's in 4 decimal places. So in such type of questions we will use continuity correction, in which accuracy measure is very minute. So in the solution, x is normally distributed with mean 0.6140 and variance 0.0025 square. Then we have to find the probability x less than 0.6080. Actually, whenever we are measuring x less than 0.6080, it means this point 0.6080 must not be included in the probability, because probability x is up to 0.6080, but the point 0.6080 should not be included. The mean of this distribution lies in the center, and the ordinate is almost 160, and mean is in the center 0.614, and 0.608 is on the left side of the 0.614, the mean. So it is here at the left tail, and we will draw a line here at 0.608, so that the area below this point should be shaded, but this point is actually not included. So we have to find one more point on the number line which comes before 0.608. So the standard deviation is up to 4 decimal places. So continuity correction will be used 0.0005, and whenever we subtract 0.0005 from 0.608, which is actually on the number line, then we will locate a point which is mentioning with this red arrow. Before this point, uh, we are mentioning here it is 0.0025, which is the standard deviation up to 4 decimal places. So correspondingly continuity correction is 0.0, again 0, one more 0, and then 5 will be used. So this is our continuity correction up to 4 decimal places. This would be added or subtracted in the points according to the requirement. So the requirement is probability less than 0.608. So we have to find this point first, and this point is obtained by subtracting this continuity correction from 0.608, and then we will find the probability. Now I am solving it. Probability x, capital X should be there, less than equal to 0.608, which is mentioned in the statement. Now I am replacing it less than sign with less than equal to sign, in which a point which is mentioning here should be added in the shaded area. So 0.608 minus 0.0005, then we will have 0.6075. Okay, which is firstly convert into the standardized variable z, because x is a normal variate, and normal variate should be converted into the standardized variable z. So z less than equal to a point, z should be capital because it's a variable, and x also a variable, so x and z both should be variables, should be in capital letters. Okay, now we will take this point 0.6075 in the z-score formula, and it's less than equal to, so we are writing here point less than equal to. Z-score is 0.608. Okay, now we will find z-score at x is equal to 0.6075. Z is equal to x minus mu over sigma. So we will substitute all three values x, mu and sigma in the z standardized variable. So z is equal to, x is in our case 0.6075 minus mu in our case is 0.614. Now whole divided by its standard deviation divided by 0.0025, which gives us, first we calculate this in our software, and calculation gives us answer minus 2.6. So 2.6 is on the left side of the mean, because on the z scale in the center there should be 0, and minus 2.6 is on the left side, so we will write it z less than equal to minus 2.6. When there is probability z less than sign, then we can write it as phi, capital Phi of. So we have to write probability z less than by phi of minus 2.6, and we know that we can obtain this value from the table number 9, in which standardized normal cumulative distribution function is given, and there should be z in the vertical form, and we can pick our value minus 2.6 from this line, from this column, and minus 2.6 is this one, and correspondingly against 0 its value is 0.00466. So come to the solution, and we will write it here 0.00466. As we know that we have to find the answer in the percentage form, whenever we have to convert percentage result, then we multiply this value by 100%, and answer will be converted into percentage. So its answer is now 0.466. We can directly write it as 0.466 percentage. This should be comes first, so we write it before the probability. Firstly, we find the values of z-score at x is equal to 0.6075. Then we will solve the probability. Now we will solve the probability more than 0.617. So we will mention on the number line a point from inner side of 0.617, because more than means 617 should not be included in the probability. So one more line is introduced which is on the right side of that point, and we will shade the probability more than 0.617. This new line is actually obtained by applying the continuity correction. So we will shade it by the green color, and green color starts from the new line, and this new line is more than 0.617. So on the number line in the center is 0.614, then arrow line is at 0.617, and more than 0.617 a point must be on the number line here, and we have to find the probability that x greater than 0.617. We have to find x greater than 0.617. So this new line, this new red line is obtained by adding continuity correction in 0.617, which is 0.617 plus 0.00005, and the value of this point would be 0.61775. So required is the probability that x greater than 0.617, probability x greater than equal to 0.6175. So this can be obtained by converting this x point into the z score. So at 0.6175 we will find z is equal to x minus mu over sigma. So we will substitute x, mu and sigma in it, and we will obtain the z. X is 0.6175 minus 0.614, the mean, and it is divided by its standard deviation, which is 0.0025, and calculate this point. We will have firstly we calculate it. So the numeric value would be 1.4. Okay, this 1.4 would be the corresponding point of the on the z line, which corresponds to 0.6175 on the x-axis. So we will find the probability here. We can write it here. So it is equal to probability z greater than z greater than equal to 1.4, and we know by the theorem that the table values are available for probability z less than. So for the greater than sign, we will replace it by 1 minus probability z less than 1.4, because the greater area is required, and the whole probability from starting minus infinity to plus infinity, it is 1. And for example, this is the shaded area and we have to find this one. So by the theorem, the whole probability, this is the table value which is denoted by capital phi of z, which is available from minus infinity to that point. In our case, the point is 1.4. So table gives us probability at 1.4, starting from minus infinity to plus infinity. So we have to subtract this phi of z from 1. So we will write it as probability z less than equal to 1.4. And this probability z less than 1.4 can be written as 1 minus phi, capital phi of 1.4. So in the table, the value of 1.4 would be, okay, come to the table. Okay, this is the table, and 1.4 is on the next page. The first one value, sorry, in negative, yes, this is 1.4 and the corresponding value is 0.91924. So pick up this value 91924 and write it here 0.91924 and subtract it from 1, and the corresponding value of this expression would be 0.08076. So we will write it here 0.08076. Okay, this is our answer for the probability x more than 0.617, and by applying continuity correction, answer is 0.08076. Now we will solve the next part of this question, the third part, in which we have to find the probability between 0.61 and 0.6180 inclusive. As I mentioned it with red color, in the center there is the mean 0.6140 and height is maximum ordinate is at 160, and one point is on the left side which is 0.61 because it is less than 0.614 the mean, and 0.618 is more than 0.614, so it should be on the right side, which is already mentioned. So we will place one more arrow here. So one point is on the right side of the mean and one point is on the left side of the mean, and we have to find the probability between these 2 points. But the word, there is a word inclusive, which shows that the area from one green point to other green point is not required. We want to include these green lines in the shaded area. If we want to include these points into the shaded area, then we have to apply one more line beyond these two arrows. One line before the green arrow of the left side, one line after the green arrow on the right side. So we will have area which is more than this area which is shown by these arrows by introducing two red lines which are beyond the green lines, one on the left side and one on the right side. So we will shade our area from red line to red line, which will actually increase your total shaded area which was previously colored. So whenever there is a word inclusive, then you have to point two points introduced on the number line beyond your actual points. So we will increase the shaded area now from red line to red line. Now I'm going to color it so that you can easily understand that whenever inclusive word is in the statement, then and continuity correction is required. And when continuity correction is required, whenever your values of x are very short interval, exist for a very short interval. Here all are in the 4 decimal places. It shows that actually measurement scale is very narrow. 4 decimal places are required, so we are using 0.0005 4 decimal places in the continuity correction, and inclusive word increases the shaded area. So first we find the z value on these new points introduced. First point is on the left side, which is here, and one is on the right side. Since on the number line 0.617 is on the left side, and red line is before 0.61, so 0.61 minus 0.0005, and whenever it is on the right side you have to add continuity correction, and on the left side you have to subtract the continuity correction. So because on the number line this red line is after 0.618, so we add 0.0005, and this point is before the green point. Therefore we have to subtract 0.0005 from the actual point, which is 0.61. Okay, so minus 0.005. Now we will find the probabilities at these 2 points, and after applying the continuity correction. I am writing here the between area 0.61 to 0.6180. Since there is word inclusive, that's why I'm using 0.61 less than equal to x less than equal to 0.618 is equal to probability. After applying the continuity correction, we can write it as in 4 decimal places first, and then by subtracting and adding these 2 points from the given values, we will have 0.6110 minus 0.005. This value is actually 0.6095 less than equal to capital X, because we are not converting in Z, it's again in X. By adding this continuity correction in 0.6180 we will have 0.6185. Yes, 85. Okay, now we convert these two values of x into z scores by applying the z statistic, which is equal to z is equal to x minus mu over sigma. So at x 0.6095, z would be z would be minus 1.8. So we will write it here at x is equal to 0.6095. After clearing the drawings, we will have this as minus 1.8. So this is the value of z. So at x is equal to, oh, this is not actually comma. This formula is of z. So I'm writing here 6094. So this would be our z is equal to. So in the next step, the same formula of z would be used with the new values 0.6185. So I'm writing here z z is equal to 0.6185, and now we will solve it and get the answer, and our answer is our answer is 1.8. This shows that both of these points are equidistant from the mean mu. Mu lies in the center, minus 1.8 is on the left tail, and 1.8 is on the right tail. So on these 2 points, we will write here probability minus 1.8 less than equal to z less than equal to 1.8, which are the corresponding values in the z. Now, by applying the theorem, we can find phi of b minus phi of a. This is the theorem. So phi of b in our case is 1.8, and phi of a is minus 1.8. So on the number line, 1.8 is on the right side, which has more area. So we'll write it at first. Phi of 1.8 minus phi of minus 1.8. So from the table values, we can substitute the results in it, and from the table we will see the results. Okay, 1.8 against the 0 is 0.96407. Okay, we will substitute its result under the new line 0.96407, and now we will locate minus 1.8 in the table. Minus 1.8 is not on this page, so we will come on to the previous page, and in the bottom this is minus 1.8, and correspondingly against the 0 value it's 0.03593. So we will write here as 0.035. We missed, it was 3 5 3593. Okay, so we will write here 93. So after solving this expression here, we will have the result as 0.92814. So we will write this result here 0.92814. We can convert it in percentage by multiplying it 100%. So from the book we can see the result is in percentage form, so we have to convert it in percentage by multiplying by 100%. Okay, or simply we can write it as 92.814%. Okay, now come to the last part of this question, equal to 0.615. Whenever we have to find the probability in the continuous variable probability x is equal to any point, it is always equal to 0. The probability in a continuous random variable at a specific point is always equal 0. But if we want to apply continuity correction, as in this case, that is in which 4 decimal places are required in the solution, so we have to mention 0.615 first in the figure. In the middle there is 0.614, the mean, and our required point, which is 0.615, is more than this 0.614, so it comes on the right side of the mean. So we will locate a point using a green arrow on the right side of the mean, which is 0.615. At this specific point probability is 0, but applying the continuity correction, two lines would be introduced, one before the green line and one after the green line. So from red line to red line the area would be shaded, which is actually not equal to 0. There must be some answer because there is some shaded area which gives you the probability at x is equal to 0.615. Now actually the point is, how can you get these 2 points on the red line? The green line, the between center line, is at 0.6150. We can write it 615 or 6150. We have to add and subtract our continuity correction to find these 2 points. For example, this left point and this right point. Right point will be obtained by adding continuity correction, and left point is obtained by subtracting continuity correction from 6.615. So this is our continuity correction, 0.0005. This continuity correction would be added in the given point, and the same continuity correction is adding this point. The central point is 0.615, so we have to add both of these points. So at x is equal to 0.61 0.6145. By adding these two 145 and corresponding z is obtained by subtracting 0.6145 minus 0.614, the mean, and divided by the standard deviation, which is equal to 0.0025, and the expression would be calculated by the software, and this gives us the result 0.2. So the lower limit of this shaded area is 0.2. Now we will calculate the same thing, the same step for the upper limit. So we will copy it here, and upper limit is by adding 0.615 and 0.0005 continuity correction. So it would be 0.6155. So we will write here 6155, and the result is 0.6. Now we will convert it as probability 0.2 less than z less than 0.6. Now we will use the theorem and write it phi of b minus phi of a. So phi of 0.6 will come first, and phi of my 0.2 will be come later. So from the table we can observe these values, write it down here, and then subtracting we can get the final result. So the table gives us the result at 0.6 and 0.2. So from here at 0.2 it's 0.57926, and at 0.6 it's 0.725. So we will write here their corresponding values and subtract them and get the answer. So thank you so much. Allah Hafiz.